Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 176. Please turn to it. Number 176. Problem number 173 is what we're going to work on. Problem number 173. In problem 173, they tell us that to start out with, we have W number of women. The number of women is W, and we have M number of men. And then what happens? We are told that three more women, and two more men are added. Well, let's find out what that is. Three more women are added, which means new number of women is W plus 3. Two more men are added, which means the new number of men is M plus 2. And the question simply is, what are the odds of picking a woman at random? Well, the odds of picking a woman at random is very straightforward. It's simply number of women divided by the total number of people, which is the sum of the men and the women. The number of women, we already know what that is. That's W plus 3. And the total number of people is number of women, which is W plus 3, plus the number of men, which is W plus M, M plus 2. And that's it, we are done. We just have to simplify it. 3 plus 2 is going to be 5. So it's W plus 3 over M plus W plus 5. Well, that's it. That's our answer. And that's answer choice E. So this is one way to do this problem. Another way to do the same problem without the algebra is to just plug in numbers for the W and the M. And you could do that, although I don't think it's necessary here because it's a very simple algebra problem. It's nothing complicated. But if you wanted to do that, you could actually make up the numbers for men and women. Let's pretend there are 10 women and 15 men to start out with. And then we add three more women, so now we have 28 women. So it's we're going to add 3 more and 2 more men. So we have 13 plus 17, and that gives you 30. And the question is, what are the odds of picking the women? Well, the odds of picking the women in this case will simply be, since there are 13 women, the odds are going to be 13 over 30, because the total number is 30. And then all you have to do is go through all the answer choices, wherever we see W, replace it with 10, wherever you see M, replace it with 15, until you come upon an answer choice that works out to be 13 over 30. For example, here, W is 10, so it's going to be W plus 3, which is going to be 13, and then M plus W is 25, M plus W plus 5. There you go, that's your 30. And it matches this quantity, matches that quantity, and therefore the answer is E. So that's another way of doing it. But like I said, I don't think it's actually necessary. Let's do the next one, shall we? And that's called plugging in technique. Plugging in techniques come in quite handy in a complicated algebra problem. Something as simple as this, you might as well simply do the algebra and be done with it. The next question says, how many prime factors of 1750 are there between 1 and 100. So they want us to count all the prime factors of 1750 that lie between 1 and 100. Nothing about that. Well, let's find out. 1750 is what we have. The thing is that if we were to continue with 1750, if we were to continue doing our work with 1750, that's going to be very cumbersome, that's going to be very tedious because it's a very large number. As I always remind you, when you're facing something like this, something that is bulky, cumbersome, tedious because it's too much to do at once, well, then logic dictates that if it's too much to do at once, then break it up. Break it up into two parts. So we're going to break it up into 10 times 175. Because 10 times 175 is your 1750. How many prime factors are there of 10? Well, 10 has only two prime factors. 10 is made up of 5 times 2. Those are the two prime factors, 5 and 2. So that's 2 right there. Let's work on 1750, shall we? Divided by 5. Why divide by 5? Our job is to find the prime factors. And when you're looking for the prime factors, you have to start with the lowest prime factor that you can find. The lowest prime number is 2. We have to start with 2 and then 3 and then 5. Obviously we can't start with 2 because it's an odd number. Why didn't we try 3? Because how do we know if a number is divisible by 3? If the sum of the digits of that number is divisible by 3, then the number itself is divisible by 3. Here we have 175. 1 plus 7 is 8. 8 plus 5 is 13. 13 is not divisible by 3. And therefore, 175 will not divide evenly into 3. So we can skip 3, we go to 5. How many 5s in a 1? 1 has no 5s. That one goes and joins this guy, becomes 17. How many 5s in a 17? 17 has 3 5s. The remaining 2 is going to go and join this guy, it's going to become 25. How many 5s in a 25? 25 has 5 5s. Voila. Let's go one more round. 35, we can divide that into. Now how the hell did I get 35? That is not what I have. That's not what we are not given 1750. We are given 7150. I am so sorry. 7150. We could have continued here. Had we continued here, we would have gotten 7 and a 5. This is an interesting question. Let's continue. Since I met the boo-boo, let's continue. So we'll pretend that we are doing two problems. How many prime factors are there of 1750 between 1 and 100? Since I met the boo-boo, let's continue with the boo-boo. And now we'll do the next question that is in the book separately. We're going to pretend that we're doing two problems. So how many prime factors of 1750s are there between 1 and 100? Well, here we have 35, and we divide it by 7. Technically we should divide it by 5 because 5 is more than 7. And then we end up with a 7. So the prime factors of 1750 that are between 1 and 100 are 2, 5. And now once we count that 5, we cannot count this 5 and this 5 again. That's it, we're done with it. And 7. It has 3 prime factors. 1750 has only 3 prime factors that are less than 100. That's it. We are done. There is nothing else. Let's do the next one, shall we? That fall between 1 and 100. Let's do the next one. The problem that is actually given to us is not 1750, it is 7150. So that's it, 7150, break it up into two parts, 10 is equal to 5 times 2. So those are two factors right there, and then we have 17, we divide by 5 again, because we're not going to, it's an odd number, we can divide by 2. 7 plus 1 is 8, 8 plus 5 is 13. Of course the sum of the digits is not going to change because it's the same digit in a different order. So let's divide by 5. How many 5s in 7? 7 has 1 5. The remaining 2 is going to go and joins this guy, becomes 21. How many 5s in a 21? 21 has 4 5s. The remaining one is going to go and join this guy, becomes 15. Becomes 15. How many 5 in a 15? 15 has 3 5s. Voila. I knew it was supposed to be more interesting than the banal, ordinary thing that we just did with 1750. Now we have 143. Things are going to get prickly. Okay, listen carefully. We're going to go through very quickly. We're going to go through the list. 143 is what we're looking at. Can we divide that by 2? Obviously not, because it's not an even number. Can we divide it by 3? Well, let's find out. 1 plus 4 is 5, 5 plus 3 is 8, the sum of the digits is 8, 8 is not divisible by 3, therefore we can't divide it by 3. Can 143 be divided by 4? The answer is no. Anything that can be divided by 4 can also be divided by 2. It has to be an even number before we worry about dividing it by 4. It doesn't mean that all even numbers are divisible by 4. What it says is that if a number is divisible by 4, it better be an even number. So 4 is out of the question. Obviously we can't divide by 5 because it doesn't end in a 5 or a 0. Can we divide it by 6? The answer is no, because it's not divisible by either 2 or 3. For a number to be divisible by 6, it has to be divisible by 2 and 3, which means it has to be an even number to start out with at the very least. If it's not even an even number, don't worry about whether or not it's going to be divided by 6. It's not. It has to be divisible by both 2 and 3 if it's divisible by 6. Can we divide this by 7? No. The answer is no, because we know that 140 is divisible by 3. 140 is divisible by 3 because that's just 70 times 2. And if we divide this by 3, we're going to have a remainder of 3. If we divide this by 7, we're going to have a remainder of 3. Can we divide this by 8? Obviously not, because it's not an even number. What about 9? Obviously not, because it's not divisible by 3. Anything that is divisible by 9 must also be divisible by 3. It's not. We already established that. Can we divide it by 10? Obviously not. It doesn't end in a 0. Can we divide it by 11? Well, let's find out. Let's find out. 11 is made up of 110, which are 10 11s, and that is going to leave us with 123. 123 cannot be divided by 11. Or rather, that's going to leave us with 23. 23 cannot be divided by 11. 24 can be, which means had it been 144 would have been divisible by 11. Is that right? Did I make a mistake? 110, it will leave us with 33. 143 minus 110, it leaves us with 33. But 33 is divisible by 10. Oh, well, there you go. We're done. It's 13 times 11. We're done. Well, that was very easy. 33 is 3 times 11, and this is 10 times 11. Well, there you go. We hit a jackpot. So, that's it. Those are the factors. 11 times 13. That's it. We are done. So, what are the prime factors of 7,150 that lie between 1 and 100? And those factors are, we should erase this part. This is from the previous work. Those factors are prime factors are, let's go in sequence, okay? We must go in order. The smallest one is 2, then comes, there is no 3, then we have a 5, and then we have an 11, and then we have a 13. Voila. It has 4 prime factors that are less than 100. 7,150 has 4 prime factors as opposed to the one we did before, which was 1,750. That's it. We're done. The answer is 4, and that is answer choice B. I'll see you tomorrow, okay? Now, I hope you understood how we found this thing, because once we got to the 10 did not work, and I was wondering if the 11 would do the trick. 11 did do the trick, because what you do is whenever the number is like this, break it up into the multiple of 10, because if it's large enough, obviously, you're going to have enough to go multiple of 10. Subtract that from it right away, and then ask yourself, what's the leftover? The leftover, once we subtract 110 from 143, the leftover is 33. And then you can immediately see that 33 is 3 times 11. Therefore, 143 is 13 times 11. And they both happen to be prime numbers. So we are done. That's it. I'll see you tomorrow, okay? Bye now.